Derivation of the equations of motion for uniform acceleration. Firstly, you won't be expected to derive these equations, but you may just want to know where they come from. The terms we're going to use. I'm going to use S to represent the vector displacement in meters. Sometimes X is used to represent displacement. U will represent the initial velocity of the body in meters per second. V will represent the final velocity of the body in meters per second. A, the acceleration in meters per second squared, and T, the time in seconds. Acceleration is defined as the rate of change of velocity, or we can write it as final velocity minus initial velocity, which is the change in velocity, divided by the time taken, giving the rate of change in velocity. We can easily now put this into symbols. A for acceleration is equal to V for final velocity minus U for initial velocity, divided by T for the time taken. Rearranging this equation to V equals U plus AT gives us our first equation of motion. For the next equation, I'll use this simple velocity time graph. Putting our symbols on, here we have the initial velocity U, the final velocity V, and the time T. Now, displacement is equal to the area under a velocity time graph, this area here. And we can find this as the average height of this shape multiplied by the time. The average height is U plus V over 2 multiplied by the time. This gives our second equation, which I'll call equation 2. Here we have equation 1 again, which I'm going to rearrange for t. And equation 2, now substituting in for this t with this value, we can write that S is equal to U plus V over 2 times the symbol here from equation 1 of V minus U over A. This gives V squared equals U squared plus 2AS, which is going to be equation 3. Back to equation 1, and I'm going to square both sides, giving me a term for V squared, which I can place into equation 3 in place of this V squared, to give U plus AT squared is equal to U squared plus 2AS. Rearranging gives me S equals UT plus a half AT squared, which is equation 4. So we've derived all 4 equations, and I'm just going to list them here. Equation 1, V equals U plus AT. Equation 2, S equals U plus V over 2 times T. Equation 3, V squared equals U squared plus 2AS. Equation 4, S equals UT plus a half AT squared. Just to stress, these equations will only work when there is uniform acceleration. And again, you are not expected to be able to derive these equations, and they are all listed on the datasheet, so you don't even have to remember them, although it might save you some time.